New section is entitled Bessel's equation. Bessel's equation is in this form: x squared y double prime plus xy prime plus x squared minus v squared y equals 0. We'll assume that v is a non-negative number. What does non-negative mean? There are three types of numbers: negative numbers, the number 0, and positive numbers. Well, non-negative means not negative. That means 0 or positive. That's exactly what v is greater than or equal to 0 means. Now, to solve such an equation, the equation once again being this, to solve such an equation, we assume, like we have been assuming, that the solution will be the summation of c sub n x to the n plus r. So y prime will be the summation of n plus r, cn, x to the n plus r minus 1. And the second derivative will also be a summation of n plus r times n plus r minus 1 times c sub n times x to the n plus r take away 2. In all three cases, the summation goes from 0 to infinity. Now, I'm going to rewrite this using the summation way of writing y prime, and y double prime. But please don't forget it equals 0. So 0 is equal to y double prime, which is the summation of n plus r minus 1 c sub n x to the n plus r minus 2. But I'm multiplying it by x squared. When you multiply that by x squared, you just get x raised to the n plus r. Now plus y prime, the summation of n plus r times c sub n x to the n plus r minus 1. So when you multiply it by x to the 1, you just get x to the n plus r plus x squared plus the summation of x squared minus v squared times cn x to the n plus r. Now, so we have 0 is equal to this first summation, which we're not going to do anything to, plus the second summation, which once again we're not going to do anything to. Separate it down correctly. The third summation I'm going to distribute and make it two summations. The summation of x squared times cn x to the n plus r. So it's going to become the summation of cn x to the n plus r plus 2 minus, just say minus, the summation of v squared cn x to the n plus r. Now, the first three of the four summations, first, second, and the fourth, they all have an x to the n plus r. In fact, they all have cn x to the n plus r. So I can write them down as one summation. Summation of n plus r times n plus r minus 1 plus this n plus r plus, minus v squared. Minus v squared. And this is all times Cn x to the n plus r. Plus this lone one. Plus the summation of Cn x to the n plus r plus 2. Now, we want to simplify what's in this bracket. It's this plus that minus that. Now let's combine the first two terms. They both have an n plus r in it. So we can factor out the n plus r. Now how many n plus r's do we have? Well, we have this many, and we're adding one more. I can think of this as plus 1 n plus r. So when you add 1, this kind of cancels. Minus the v squared. So we have n plus r times n plus r, which is n plus r squared minus v squared. Okay, so let's write that down. 0 is equal to the summation of this mess, which is n plus r squared minus v squared times c sub n x to the n plus r plus the summation of c sub n x to the n plus r plus 2. Now, save a little time and space, we can factor out an x to the r, which just means the plus r goes. That is, the first power of n will just of x will just be x to the n. The second one will just be n plus 2. Now, we'd like to get the power of the x's to both be the same. And between this power and this power, so I'm going to let n be k, excuse me, over here, and over here, I'm going to let n plus 2 be k. So we get x to the r. In the first case, instead of n going from 0 to infinity, n just becomes k. Summation as k goes from 0 to infinity of k plus r squared k plus r squared minus v squared c sub k x to the k plus this summation. Summation is k goes from some number to infinity. So like it says, n plus 2 is going to be k. Well, since n starts at 0, k is going to start at 2. And if I bring the 2 over to the other side, n is replaced with k minus 2. So c sub n, k minus 2, x to the n plus 2, well it says n plus 2 is equal to k. So we have this. Now, between the starting values of k, over here says k starts at 0, here k starts at 2. The larger number is 2. That is, the terms where k is less than 2, I want to break off. So first I let k be 0. 0 plus r is r squared minus v squared c sub 0 times x to the 0, which is 1. I won't write the 1 down. Now k is 1. So you have 1 plus r, which I'll write down as r plus 1 squared minus v squared c sub 1 x to the 1 plus, now this we have to add up from 1 to infinity, from 2 to infinity, and over here we're adding up from 2 to infinity. So I can write it down as one summation from 2 to infinity, and notice they both have x to the k. So I'm going to have this piece right here, k plus r squared minus v squared times c sub k plus c sub k minus 2. C sub k minus 2. And that's going to get multiplied by x to the k. And the whole thing is being multiplied by x to the r. And remember, it's supposed to equal 0. It's supposed to equal 0. So I want this to be 0, this to be 0, and for this to always be 0. So if I'm adding up 0x to the k, well, that's always 0. I'm just adding up zeros from 2 to infinity. You add a lot of zeros, you get 0. Now, if I let c1 equal 0, everything's fine. We have r squared minus v squared should be 0. c1 is 0, and that big mess, k plus r squared minus v squared all times c sub k plus c sub k minus 2 should equal to 0. Should equal to 0. Okay. Well, if you subtract two quantities and you get 0, that means r squared should equal v squared. That is, r is plus or minus v. R is plus or minus v. Okay. Okay. So you have a little thing that's theoretically wrong. It's very bad. There's no reason why c sub 1 should be 0. There's no reason why c sub 1 should be 0. And in fact, there's even no reason to write this up here. We just took this and said it equals 0. Now, what happens when r is equal to v? And remember, when r is v, this piece is 0. That is, this piece down here is 0. So we still have x to the r in front, but r is v. And I'm going to write down this mess on the very, very last line, except instead of r, I'm going to put v. So this piece is 0. So I have v plus 1 squared minus v squared times c1 x1 plus the summation as k goes from 2 to infinity of k plus v, r is v, k plus v squared minus v squared times c sub k plus c sub k minus 2 times x to the k. Close the bracket. Now, let us look at what should have been put in that bracket. So v plus 1 squared is v squared plus 2v plus 1 minus the v squared. So what's in the red is just 2v plus 1. What's in the red is just 2v plus 1. So we get 0 is equal to x to the v times 2v plus 1 c1x to the 1 plus the summation. Like it says here, v squared. Well, what is k plus 1 v squared minus v squared? Well, this is k plus v squared, k squared plus 2kv plus v squared. And if you take away v squared like it tells you to, you just get k squared plus 2kv. And both of these terms clearly have a k in it. So we get k times k plus 2v. So it's the summation of k times k plus 2v ck plus ck minus 2. Let me see something. I guess I didn't need that bracket. And all of this gets multiplied by x to the k. So we have this, but it still equals 0. It still is equal to 0. So we have that 2v plus 1 equals 0, and that equals 0. K times k plus 2v c sub k plus 2 c sub k minus 2 is identically the number 0. Now if 2k plus 1 is 0, v must be negative a half. So that should be negative 1. So v is negative a half. And let's see what c sub k is going to be. If I solve for this, that is, I bring that to the other side, the right side will be negative c sub k minus 2. And this number times ck will equal to negative c sub k minus 2. But I'm going to divide by this number, k times k plus 2v. That is what c sub k equals. Now, this is all when r is b. Get rid of what I don't need. When r is equal to v, we have c sub k is equal to k times k plus 2v and negative c sub k minus 2. Okay, and we don't even need this. Now, since these differ by 2, you're going to have the C sub k's in terms of two different C values, like C1 and C0. For example, C sub 2 will be negative C sub 0 over 2 times 2 plus K plus 2V, excuse me. 2 times, I'm mistaken, K is 2, 2 plus 2V. I can pull out a 2 from what's in the brackets, and then I'll get 4 in front of the brackets, and 1 plus V. So C2 is in terms of C0. Now, C sub 3 will be negative 3 minus 2 is 1, negative C1 over 3 times 3 plus 2V. No, I don't think I want to factor out that 2. But you don't see that until you try. Now, C sub 4 is going to be negative C sub 2 over 4 times 4 plus 2V. So, it's negative 1 over 4 times 4 plus 2V times C2. So C2 is right above. It's negative C0 over 2 times 2 plus 2V, which turns out to be positive C0 over 4 times 2 times 4 plus, well, I'll say this one first. 2 plus 2V times 4 plus 2V. And even the 4 and the 2 that I'm erasing, I'm going to put them back, but I'm going to say the 2 first. Right. So C sub 4, we have it nicely written a little bit lower. I'm going to put it up here. It's right here. It's C sub 0 over 2 times 4 times 2 plus 2V times 4 plus 2V. Always plus 2V. Always plus 2V. Okay, I think I see a pattern. Do one more in each column. Let's have 3 in each column. So 3 sub 5, column being split up there, is negative C sub 5 minus 2, which is 3, over 5 times 5 plus 2V. So it's negative 1 over 5 times 5 plus 2V times C3. But C3 is negative C1 over 3 times 3 plus 2V. A negative times a negative is positive, which I won't write. 1 times C1 is C1. And I'll write 3 times 5 times this times that. 3 plus 2V times 5 plus 2V. And that is exactly what C sub 5 equals. You really should see a pattern emerging. C1, 3 times 5, 3 plus 2V, 5 plus 2V. If we were to do C sub 6, I'll start it off here, it is negative C4 divided by 6 times 6 plus 2V. But this is the same as negative 1 times C4, which is C0 over 2 times 4. 2 plus 2V. 4 plus 2V. So for C6, we get negative 1 times C0 is negative C0. We get 2 times 4 times 6, 2 times 4 times 6, times 2 plus 2v, 4 plus 2v is right here, and now 6 times 2v. 6 plus 2v, excuse me. And hopefully you see your pattern. When you have, so all these subscripts are even, so I'll call them 2n. Now the numerators, they go from negative to positive to negative. So that's negative 1 to the n, and they all have C0. They all have C0. And then first I see all the even numbers. 2, 4, 6, 8, 10. Oh, it stops at 6. It stops at that subscript. 2, 4, 6. When it was 4, it stops at 4. 2 times 4. So we're going to have 2 times 4, dot, 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 up to that value. Up to 2n. And we're going to have those same numbers again. The 2, the 4, the 6, the 8, 2 plus 2v. 4 plus 2v. 6 plus 2v. And we stop at 2n. We're going to have 2 plus 2v, 4 plus 2v, dot, 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 up to 2n plus 2v. And have a very similar thing with the odd values, the odd subscripts. C sub 2n plus 1. Well, it's negative and then positive, so it's negative 1 to the n, C1. And just like the other ones, they have the odds. And if you want, you can put 1 in front. You have 1, 3, because you stop at when the odd is 3. 1, 3, 5, I stopped at 5. You can have 1, 3, 5, all the way up to 2n plus 1. Alright, so we're going to go up to 2n plus 1. I ran out of room here, but also times in the bottom is going to be 3 plus 2b times 5 plus 2b all the way up to 2n plus 1 plus 2b. So now I have C sub the evens, and I have C sub the odd value. Now, what would be nice is if we let C1 equal 0. That is, this will be 0. That would be 0. So this is for R is equal to B. I'm going to define in a moment a new function. It has a name called gamma, but it's just a function. It's just a function. I am going to define C sub 0 equal to 1 over 2 to the v times the gamma. That's the symbol for gamma. It's just like F or G, gamma of, I guess, 1 plus V. But the gamma function is called, where gamma of 1 plus A is, let's see, it's going to be A gamma of A. We have that property for this function. That's what the function is. That's a property of the function. Now, let's see what that means. If you have gamma of 1 plus V, well, that's going to be V times gamma of V. Now, gamma of 2 plus V, think of that as gamma. See, if you have gamma of 1 plus anything, you get the anything gamma of the anything. Well, 2 is 1 plus 1. But it's 2 plus V is 1 plus V plus 1. So this here is my A. So I'm going to get A gamma of A. So you have gamma of 3 plus V. You're going to get, you can think of it as gamma of 1 plus V plus 2, where V plus 2 is my A. So I get V plus 2 gamma of V plus 2. But here's where it's very interesting. I can simplify that second one. I have V plus 1 times that. But that is this. That is, it's that. This is V gamma of V. The line below, we do the same trick. It's V plus 2 times gamma of V plus 2. But gamma of V plus 2 is this. It's V plus 1 V gamma of V. But if you take a look, that's kind of what we have in the bottom. Is kind of what we have in the bottom. We have 2 plus 2V, 4 plus 2V. Okay. What we can do more in the bottom is the following. We have negative 1 to the n, c to the n. Now, I can pull out a 2 from here n times. After all, it's 2 times 1. This is 2 times 1, 2 times 2, 2 times 3, all the way up to 2 times n. So I'm going to have 2 to the n, but then I have the 1, the 2. You know, remember, this is 2 times 1. Just ignore it when I say 2. 2 times 1. I'll say it's awkward. 2 times 1. 2 times 2, 2 times 3, 2 times 4, 2 times 5, 2 times 6, all the way up to 2 times n. Well, I factored out all those 2's, so now I'm left with 1 times 2 times 3 times 4 up to n. Well, that's n factorial. Now, in here, if I factored out a 2, I'd have 1 plus v. And if I factored out a 2 from here, I would have 2 plus v, etc. Factored out a 2 from there, I'd have n plus v. But how many 2's did I factor out? And the answer is n of them. That 2 was 2 times 1, 2 times 2, all the way up to 2 times n. I factored out another 2 to the n. So I have the 2 to the n that I have in the front times another 2 to the n. Why, that's 2 to the 2n. This is 2 to the 2n. Now, it turns out that that's more like what I have above in red. So we went a little bit further, and we got a better way of writing c sub 2n. It's negative 1 to the n, c sub n, 2 to the 2n, n factorial, and then we start having 1 plus v, 2 plus v, all the way up to n plus v. Okay. So what does that mean? How can we use the gamma function to get anywhere with this? How can we use the gamma function? So I said that, oh, this should be c sub 0. C sub 0. Okay, so what I have is negative 1 to the n times this. 1 over 2 to the v gamma of 1 plus v. All over 2 times 2 to the n times n factorial times this stuff. But that stuff is somewhat like a gamma function. It looks like a gamma function. If we want to have v plus n all the way down to v plus 1 times v times gamma of v, well then we're going to start off with, if we want to end in 2, that has to be one more. So we want to end with n, so we're going to have n plus v plus 1. Now, if I divide by gamma of v, we have exactly what we want, if I'm not mistaken. We have exactly what we want. Okay, so everything I said was true. The thing is, I think it would be best if we left gamma of 2 plus v as this. That is, not to put that. Not to put that. So then gamma of 3 plus v would just be this. Well, let's work it out. Gamma of 1 plus anything is the anything times the gamma of the anything. it has the v plus 2 times gamma of v plus 2, or 2 plus v, is this. It's v plus 1 times gamma of v plus 1. Now, what if we keep doing this? What would gamma, what do you think gamma of n plus 1 plus v would be? Which is the same as gamma of 1 plus v plus n. Well, it would be v plus n times gamma of v plus n. But if we keep expanding, we get v plus n times v plus n minus 1 all the way down to v plus 1 times gamma of v plus 1. That's what we get. Okay, and now what's going to happen there is the following. We have that this is equal to all of this. If I divide by this last gamma, I have this over here, gamma of n plus 1 plus v, divided by gamma of v plus 1, it's going to equal to everything else. It's going to equal to v plus 1, v plus n, excuse me, all the way down to v plus 1. But that's exactly what I have here. That's exactly what I have here. So c sub 0 is that. So we have negative 1 to the n times that, divided by this, there it is, times this piece. But that piece is nothing more than gamma of n plus 1 plus v divided by gamma of v plus 1, or gamma of 1 plus v. And what's going to happen is that's going to cancel. That's going to cancel. And we're going to have the negative 1 to the n times that 1. This is going to end up in the bottom. So it's going to be 2 to the 2n plus v times n factorial times n factorial times this gamma function times, in the bottom, we're going to have gamma of n plus 1 plus v. So c sub 2 sub n, and r is v. Finally, it's going to be negative 1 to the n over 2 times 2 sub n plus v times n factorial times gamma of n plus 1 plus v. So we're just deriving this. We went through a lot of headaches to do this. We don't even need the last line. I thought we would. Now, this whole time, we've never done anything to v. V, we never actually added stuff to v. Maybe we said 1 plus v, but we never said that was 2v. V was not touched. We never divided by v's. The v's were never touched. Which means that if I say if I say r, remember r was able to equal v or negative v? If r was equal to negative v, then c sub 2n will just be negative 1 to the n divided by 2 to the 2n minus v n factorial times the gamma function of n plus 1 take away v. Okay, so we have our two results here. One where r is v, and the other one where r is negative v. Okay. Now, remember that we'll call it J sub v. One of the answers, well, call it y for now. Remember that y was equal to the summation of c sub n x to the n plus r. But I can factor out an x to the r, so sometimes the summation of cn x to the n. And n was supposed to go from 0 to infinity. N goes from 0 to infinity, and it turned out that r was v. R was v. Now, it turned out that when the subscripts were odd, we got 0. So this is the same as x to the v. The summation as n goes from 0 to infinity, but it's going to be c sub 2n. So when n is 0, this is 0, even. When n is 1, that's 2. When n is 2, that's 4. Same with the power. Remember, the subscript, the power of x have to match. So we have that. And you know what? It doesn't matter, but I'm going to put the x to the v back. N plus v. N plus v. Okay. So now, that's what y equals. Let's put it down up here. Y, the solution, is the summation as n goes from 0 to infinity of c sub 2n times x to the 2n plus v. Let us plug in c sub 2n. The summation as n goes from 0 to infinity of negative 1 to the n over 2 to the 2n plus v times n factorial times the gamma function of n plus 1 plus v times x to the 2n plus v. Now remember, if you have a to the c and you divide it by b to the c, you can divide the a and the b first and raise it to the common exponent c. Now, you have x to that, and you have 2 to that. So we can think of this as a summation as n goes from 0 to infinity of negative 1 to the n over n factorial times the gamma function of n plus 1 plus v times x over 2 to the 2n plus v. That is one solution. We'll call that y sub v. We'll call that y sub v. Now, get rid of all of this stuff. And now we're going to say, you know what? R is not v, R is negative v. We have y is equal to the summation of Cn x to the n plus r. So it's the summation of C sub n x to the n minus v, because r is now minus v. But we don't just want n, we don't want the odd subscripts. So instead of calling C sub n, I'll call it C sub 2n. But we want those to only be even too. Because when n is odd, this is 0, so the whole product is 0. So we only want when n is even. So we have 2n minus v. And if we do like we did below, we're going to get, we'll call it y sub negative v. Y sub negative v. We're going to get pretty much what we got down here, except v will be negative v. Instead of plus v, it'll be negative v. So summation that then goes from 0 to infinity of negative 1 to the n times x over 2 to the 2n minus v all over n factorial times the gamma function of n plus 1 take away v. Y negative v. These here are two solutions. Y sub v is one solution here, and y sub negative v is another solution. And these two solutions, j sub v and j sub negative v, are called Bessel functions, of the first degree, of the first kind, of order v and negative v respectively. That is, j sub v is called a Bessel function. I meant to write the word function in there. A Bessel function of the first kind of order v. And this is the Bessel function of the first kind of order negative v. So basically, just find out what v is in a differential equation. Find out what r is. Find out what r is in a differential equation, a Bessel differential equation, and then you have the two answers. Just write down this answer and plug in the real number for r when r is negative v. Okay, and also plug in the real number for v, that is the real number, the positive real answer for r. Plug it in where v is, and you'll have the second solution. The general solution, like always, will be a linear combination. Now, we talked about Bessel functions of the first kind. That leads one to believe that there's something called a Bessel function of the second kind. And we'll talk about that one, and we'll be done. Now, Bessel functions, x and n, Bessel functions of the second kind. we have y is equal to c1 times j sub v plus c2 times y sub v of x. These are functions of x's. So you get jv like we had before. Find out what r is for the Bessel equation, and then all you do is plug in the values for v, and you will have j sub v. Okay, here is another general solution. So you may say, well, what is this y function? That's a fair comment. Where y sub v of x is cosine of v pi. So we already know what v is because we solved for v. And this gets multiplied by jv of x minus j negative v of x. And believe it or not, it gets divided by the sine of v pi. So once you have what v is, all you need to do is calculate jv of x by just plugging in. I mean, here's the formula always. This is always the formula for jv. Always. All you have to do is plug in the value for v. And down here somewhere is the formula for, that's the formula for j negative v. The formula down here is for j sub v. And all you have to do is plug in the value for v. V's are always, you're going to always have what v squared equals. Just remember what the formula started with. The formula was x squared y double prime plus xy prime plus x squared minus v squared y. At some point, you're going to figure out what v squared is. And if v squared is 11, well then v would be plus or minus the square root of 11. And if v squared was 16, then v would be plus or minus 4. They're always going to be plus or minus the same number. That is plus 11 minus 11. Not positive, plus square root of 11 and negative square root of 11. Not positive square root of 14 and negative the square root of 13. It won't be plus 4 but minus 3. You're always going to solve for v squared. If v squared is any positive number, you're always going to get v is plus or minus the square root of that number. Okay. So all you do is write down cosine of v pi. And for example, if v is 2, you should know what the cosine of 2 pi is. It's 1. And plug in the value for v into the j sub negative v formula, and then divide by the sine of whatever v times pi is. If v is 11, then it's the sine of 11 pi. So let us look at one example. Suppose you have that x squared y double prime, and it's very simple. So it's xy prime plus x squared. Now, normally it's minus v squared, but let's suppose I have a third. The Bessel function is x squared y double prime plus xy prime plus, in brackets, x squared minus v squared y equals 0. Well, x is x, square is square, y is y, double primes plus x, y prime plus, basically, v squared is 1 over 9. So v is plus or minus a third. So all you have to do is go back to the y sub v formula. All you have to go back to is the y sub v formula and plug in 1/3. And remember, that's the y sub v formula. So y sub 1/3 is just the summation, and then goes from 0 to infinity of -1 to the n times x over 2 to the 2n plus a third divided by n factorial gamma of 1 plus a third, or there's the n, plus 1 plus a third. Well, 1 plus a third is 4/3. And that's y sub a third. Nothing was hard there. Absolutely nothing was hard. Y sub negative a third is the summation. N goes from 0 to infinity. Just put 1/3 there. We already put the negative, okay? So it's -1 to the n times x over 2, 2n minus a third over n factorial times gamma of n plus 1 minus a third is 2/3. So we take this here, and all we do is we put it right there. So v is 1/3. A third of pi is 60 degrees. The cosine of 60 degrees we're supposed to know. 30, 60, 90, 1, 2, square root of 3 is square root of 3 over 2. This is just the square root of 3 over 2. And the sine, remember v is still a third, so the sine of 1/3 pi, oh, this was 60 degrees. The cosine of 60 degrees is adjacent over hypotenuse. It's 1/2. And the sine of 60 degrees will be the opposite over the hypotenuse. And the 2's will actually cancel. Well, actually, that's not true. That's not true. So sorry. It won't cancel because of this piece. Remember, if you have 5 times 7 minus 11 divided by 5, you can't cross out the 5s. You have to divide that by 5 as well. Okay, so this will be pretty much the answer, except you need to type in j 1/3 x and j minus 1/3 of x, which I actually wrote down on the other page. There's j 1/3, there's j sub negative 1/3. And that will give you the final answer. Okay, that completes the section on the Bessel equations. And a little beginning of gamma function.